Welcome to session 2. In this session we're going to be looking at normal brain development and individual reactivity. Some important concepts like synaptogenesis, myelination and descriptions of sensitive periods will also be covered. So Bron, can you recap the process of brain development for us?
It's like we talked about before. It's simply a process of more and more connections between the nerves in the brain. The neurons form lots of connections called synapses. The brain develops far more than it actually needs, and then with plasticity it prunes those we don't need and strengthens those we do need. And if we have a look at the slide here, you can actually see the 3 different images with the newborn brain, the children's brain and the older brain. And in the newborn's brain there are relatively few connections. Then there's a child with massive connections. Then after the phases of pruning and sculpting, we have less connections again.
So what's this process called and how does it happen?
It's called synaptogenesis. Isn't medicine great? We keep finding great big words and really all it means is synapse, each connection, genesis. Synaptogenesis, formation of connections. Here's an image that shows synapse formation rates for a whole range of skills, including cognitive skills, and you'll be able to see, if you look along the bottom axis, there's an incredibly rapid rate of formation in the first few years, then it tapers off later. The massive production of connections or synapses prepares the brain to cope with almost all eventualities, and then it's trimmed away, which is what the pruning and plasticity is. We have that other big surge that happens in adolescence, and that's all about cognitive functions, and it's also about executive functions, which is about planning, decision making and judgment. That's the big bit of the wiring that happens in adolescence, and it's a really important time. It's also why most of us worry a lot about adolescents who are wiring under the influence of neurotoxic substances. You know, alcohol's a neurotoxin, mind-altering drugs all have potential to impact on the way we wire. And when we have kids drinking large amounts of alcohol or consuming all sorts of other things while they're in that rapid wiring phase, there are theories about what that may do long term, but there's no hard data yet.
So what do kids need to make this process happen?
Relationships, relationships, relationships. Kids to develop trust, contentment, appropriate ways to show emotion, security, they need supportive, predictable, nurturing relationships from their carer or carers. Jack Shonkoff says that the active ingredient of the environment for development is the relationship.
So Bronwyn, how are these circuits strengthened and stabilised?
They're strengthened and stabilised by the production of myelin, which is sort of like a sheath, like the insulation around an electrical wire. And myelin is made in the brain by the glial cells. Remember we talked about the fact that there were 9 glial cells for every neuron earlier? The glial cells are amazing little workers, and they make these sheaths out of cholesterol for the nerve cells. And what that means is that the transmission through the nerve cell speeds up dramatically, so it becomes much more efficient. For example, before myelination, nerves can conduct impulses at about 0.5 metre a second. After myelination, it can be up to 120 metres a second, which explains why if you hurt my toe, I'll feel it instantly.
From many years ago when I was studying neurobiology at university, the teaching then was if you didn't develop certain things at certain points in time, it was over. Now, is that still the current thinking?
No. Everything is becoming a little more elastic or plastic. Basically, what we used to refer to as critical periods, which carries that note of alarm about it being in a hurry, we now call sensitive periods or windows of opportunity. What it is that the brain is genetically programmed to expect certain information at certain times. And when that information comes at that time, we have experience expectant learning, which means the brain was waiting for it to come, it comes and it wires really efficiently. However, there's also experience-dependent learning, which can be learned at any time. That sounds fairly complicated, doesn't it? But what it means is there are certain periods of time where the brain really wires up efficiently for certain things. There are some skills that it doesn't matter, but certain things are really important. The actual hard evidence for sensitive periods in humans is limited, but there's a lot of theories at the moment, and we continue to work on it.
So what might this mean for a child that we're working with?
I think it's important to have a look at this slide. This slide, again, is theory, not fact. And you'll also notice when you look at the slide that it's from 1999 and it says critical periods. This is the postulated critical periods or sensitive periods for acquiring vision, emotional control and habitual ways of responding, and peer social skills. Interestingly, when you look at it, you'll see that the peer social skills come after the habitual ways of responding and the emotional control, which fits comfortably with what we talked about earlier. So this suggests that the really important parts for some of those windows of opportunity are under the age of 6.
Bronwyn, can you give us a practical example for all of this?
When we look at the development of the human visual pathway, we can see a really good example of sensitive periods. What happens is the light comes through the eyes to the back of the retina and then is transmitted through the brain to the back part of the cortex where it's interpreted and turned into pictures by the brain. Now, what happens is if a child is born, say for example with cataracts, and so they're blind at birth, if they're operated on within a certain time frame, they develop normal vision. And that certain time frame is quite tight and quite early, definitely within the first 4 to 5 years. If we take that same child and operate on their eyes in their teens or young adult life, although there's a functional normal eye, the brain can't see because the wires to the back don't work. The wiring hasn't happened, and so the critical period, in inverted commas, or the sensitive period, or the window of opportunity for wiring up to that part of the brain that interprets vision has passed. So that's one of those examples. Likewise, anybody who knows a young child who's had to have one eye patched, we patch kids' eyes if they're not seeing really well. We patch their good eye to force their bad eye to send messages to the brain to use it and to wire it. And we do that really commonly, and you see the best gains with patching when it's done under about 6.
That's a physical example. What about a child's emotional development and emotional regulation?
Flip back to the baby we talked about earlier. That baby that was being rocked, cuddled, soothed and looked after, that baby, as we said, is wiring for soothing and generating a map or a network in their brain for soothing behaviours. And that soothing, you can also read regulating distress. Take that same child and have somebody not come and answer its calls, or sometimes answer and sometimes shout, sometimes it's soothed, sometimes it's rough and scary. That child develops quite a different map in their head. So the wiring is for the particular set of circumstances somebody's growing up in. And you can wire for great positive experiences and you can wire for less positive experiences.
Bron, that's got the potential of sounding a little discouraging. Is catch-up possible?
Of course it is. This was really, truly, deeply discouraging when we believed that it was all over Red Rover at 6. That was really scary. But now we really do understand that the brain has plasticity throughout life. And that's a really important thing to remember. Although, as we talked about, because the building is stepwise, it's harder. You can't go back and rebuild the lower circuits. The brain has to work out ways around it. And especially when a circuit's already stabilised, the experience-dependent learning to do a workaround is harder and it takes more time, but it is possible. Remember, the brain is plastic throughout lifetime, although less so as we get older.
Bronwyn, that sounds a little bit more hopeful, but what about older kids?
As we mentioned before, there's that huge surge of synaptogenesis in adolescence around cognitive things and around planning, judgment and decision making. And of course, all of these things, as we discussed before, skills beget skills, things build on, things build on, things build on. And if you're building an adolescent brain on a brain where the lower skills for emotional regulation and all of those are okay, that's fantastic. But on the other hand, if the emotional regulation part, the lower skills aren't right, then the upper skills, when you get to adolescence, the decision making, the planning, the judgment, they're suboptimal skills, and they have to be learned quite differently if people don't have the first stuff underway. Put a different way, put really scientifically, the cortex tempers the emotional part of the brain. So the cortex actually tempers it and damps it down, and it's quite a responsive interaction, and it all matters in adolescence.
Bronwyn, it sounds like you're saying that the brain develops in response to experience and or environment. But what about individual genetics?
As always, there's a dance between the two. In the old days, we used to think it was mostly genetics. Now we're understanding a whole range of different things to do with the genetic predisposition, or what you're born with. Some workers describe it as the genes that you're born with is like the library. Your experience governs which book you'll take out of the library, which is one way of describing it that helps some people. But let's talk about trait anxiety for a moment, because this is an area where there's a strong genetic component, we think. People who've already done psychology will understand the term trait anxiety, but the other way to put it is stress reactivity or context reactivity, which means the ability of an individual to react or respond or mop up what's happening around them. Some people have high context reactivity, some have low, some are in the middle. You can take it, for example, if you're looking at children, you know those babies that can't sleep through anything, that the slightest noise they're mopping up everything. And then there's the baby that'll sleep through a building site. That baby doesn't mop up much of what's happening around. Sometimes you call it twitches and gronks. That's the way I call it because it makes sense for me. But it's a way of saying that different people will react differently to the same situation. Another way to explain it, if you imagine a policeman pulling over a car, all right? The first driver, the real twitcher, as they're pulled over, go, oh my God, I'm losing my license, I've run the red light, I've been speeding, and they get out all of a lather, all of a panic, all sweaty and all upset. Driver number two, who's kind of in the middle, might say, I didn't think I was speeding, but oh, whatever. Driver number three, the gronk, just says, officer, do you need a hand? You know, that's a different sort of a person. And there's no good or bad way to be. The community needs all of them. They're biologically really important ways of being. If you think back to the Stone Age when the wild beasts roamed the world, we needed the twitchers to hear the beasts coming. But we needed the gronks to do something about it. Because if you had a community composed all of one or the other, it'd be a disaster. They wouldn't have survived.
Ron, it sounds like everyone has their unique trip switch. What are some of the causes of this different triggering?
We think a large component of that is purely and simply genetics. Genetics governs your range of trip switch. I guess we could call it a trip switch. And sensitive caring for a child who is maybe a really, really twitchy twitcher, sensitive responsive caring early on can actually move that child just a little bit further along to a more middle of the road level of twitching. So basically it's genetic. It can be modified a little bit by sensitive appropriate caring.
Is there any other evidence for this gene-based theory?
There's a whole range of really exciting new gene-based stuff coming out around brain stuff and around outcomes. One of the most interesting ones that's starting to flicker around, based essentially out of a New Zealand study, is what we call epigenetics, where the environment acts back on a gene to turn the gene on or off. Think about it. Somebody's born with a particular gene. If that person has a normal childhood or an ordinary childhood without too much adversity, the gene never gets turned on. They go on life as though they didn't have that gene. If somebody with that gene experiences significant adversity in childhood, the gene expresses itself and tends to be associated with worse outcomes for kids. So it's a really interesting one. It's cutting edge at the moment, but it's going to be a really interesting space to watch because it tells us that some kids will be genetically more vulnerable to bad outcomes.
So, Bron, what have we learnt so far?
What we've learned so far is that there are windows of opportunity for the most efficient acquisition of certain skills. Emotional regulation is a key one of those early skills, and the sensitive period for that is very early. We've learned that experiences of a nurturing response from a caregiver gives us a strong foundation for our early circuits. And these circuits are stabilised and become increasingly efficient with myelin, but there remains lifelong catch-up possibilities and plasticity of the brain. We've also learned that there's individual variation in response to a perceived threat, and that genes play a role in reactivity, and that experience can switch some genes on or off.
And what about context reactivity?
Basically, there's individual variation in what we perceive as a threat. There's a strong role for genes in that individual variation, and over and above all of that, experience can turn some genes on or off.
Bron, this sounds like it has important implications for caseworkers' assessments and also decision making.
You're absolutely right, Al.
Because when you have a caseworker with their experiences meeting a parent with their experiences, what we see, what we perceive as risk, strengths, protective factors, all important for our assessment work, is going to be very different from one caseworker to another.
Just the same as you and I look at a similar situation and we see completely different things. But between us, we have a fabulous picture. But we each pick out different things.